clouds, which are example galaxies that we've talked about, when she plotted the apparent magnitude of each Cepheid as a function of its oscillation period p, she found that the apparent magnitude was proportional to log of p. That's the period. Since the clouds are small compared to the distance from us, they're small as in compared to their distance from us, the stars in each cloud, as in the large and small Magellanic clouds, are all at roughly the same distance from us, implying that the absolute magnitude is proportional to log p. To calibrate the period luminosity relation and find exactly which absolute magnitude m corresponds to a given period p, we need to know the distance d to at least some of the Cepheids out there. So this is actually how people figure out certain distance type stuff. Remember, we talked about it in relation to Hubble, actually, when he was trying to figure out the distance to Andromeda. Unfortunately, Cepheid stars, Cepheid variables, like all highly luminous stars, they're luminous, are rare. More luminous are rare. Only the closest Cepheids have had their parallax measured accurately, so a way of measuring the distance. A widely used form of the Cepheid period luminosity relationship is, there's a relationship for the absolute magnitude of a variable star, in this case Cepheids, and it goes as minus 2.76 log of p over 10 days, minus 4.16, in case you were wondering. Where this particular magnitude that I just talked about is in the V band, averaged over a complete period. So the scatter in absolute magnitude at a given period is about 0.3 magnitudes. If you measure the period p of a Cepheid, you can compute its absolute magnitude from this relation we just talked about. After measuring its average apparent magnitude, which is generally said with a small m, you can then compute its distance using the relation log of d over 10 parsecs is 0.2 times the small m minus the big M, which is the apparent magnitude minus the absolute magnitude, where it's averaged over a complete period. Assuming there's no extinction. Wow. Thus, Cepheids make excellent standard candles. So remember how we talked about standard candles, certain astronomical objects that may be used for, here's the explanation right now. The Cepheids make excellent standard candles. This is the term used by astronomers for an object whose luminosity is known and whose distance can thus be calculated once its flux is measured. So if its luminosity is known for some reason, in some way, then its distance can be calculated once its flux is measured. And remember how the standard candles was very important in our dark energy discussion. Basically, to prove out the expansion of the universe, we used certain standard candles. Cepheids are bright enough to be seen in the Virgo cluster of galaxies. So we had also talked about clusters at one point that include galaxies. Cepheids are bright enough to be seen in the Virgo cluster of galaxies whose distance, as measured using Cepheids, is approximately 18 million parsecs. RR Lyrae stars, the other type of stars we're talking about, can also be used as standard candles, but since they're less luminous, they can't be seen as far away as Cepheids can be seen. So RR Lyrae stars could also be used as standard candles, but they're less luminous, and so they just can't be seen as far away. And that was the lesson on